Open a workbench that smells of bronze and charcoal, and lay out a flat plate. Scribe 2 circles with dividers, one for the gear's rim, one for the root of teeth. Punch the center lightly, because every axis will reference this decision point. Cast bronze blanks first, then true them by filing until they run clean and flat. Mark the tooth spacing around the circle with the same compass step each time. This isn't hobbing, it's geometry in the hand dividers, scribes, and patience. Cut the triangular teeth by saw, and file until each land meets the layout lines. Keep the profile simple equilateral style teeth, work with small pitches and gaps. Check the circular pitch by stepping the dividers a full turn back to the first mark. When the last step meets the first, you know the count and the ratio will hold. Drill the arbor hole, square or round, but fitted to a stacked tube on the axis. Fit a thin washer to space the gear from its neighbor and keep friction predictable. Pin the gear to its collar with tiny rivet pins, so wheel and hub turn as one. Tin lead solder can secure a bearing shoe where a shaft needs a tidy nest. Now lay the case plates on the bench, front for the sky, back for the cycles. On the back plate, inscribe spirals where month names and eclipse notes will live. A pointer will walk those spirals, cell by cell, carrying calendar intelligence. On the front, cut the zodiac ring and an outer civil calendar ring that can rotate. Engrave tiny lettering with a stylus. Lines must be legible but never crowd the scale. This instrument is a language in metal. The letters teach the user how to read it. Turn to the main train. A crown gear couples the input handle to the big driver. That driver four-spoked hands a steady gear motion into the stack of wheels. Ratios cascade down shafts the way numbers cascade on a clay tablet. Every ratio was chosen because it stands close to a known astronomical cycle. Behind the neat front dial there is a forest of concentric tubes. Each tube carries a pointer, nested like reeds, inside reeds, but turning differently. Tubes save space. They let coaxial outputs pass through the same aperture. Where one motion must speed up, meshes climb to smaller wheels. Where a cycle must slow down, meshes descend to larger partners. Small air gaps between teeth prevent binding when wood dries and metal swells. Triangular teeth aren't perfect, but they are quick to cut and easy to correct. Too tight fits jam. Too loose fits chatter. The sweet spot is controlled play. Oil the pivots. Bronze on bronze will run if the faces are clean and polished. Now solve the hardest problem. Non-uniform motion of the moon. A simple gear train can't accelerate and decelerate by itself. So the maker builds an epicyclic set with a pin riding in a slot. As the pin circles, the slot forces the follower to surge and lag. That rise and fall is the lunar anomaly. Traced without numbers, only metal. Cut the slot clean and keep the pin round. Bad geometry kills the illusion. Fix that epicyclic frame to a wheel so the whole nest presses as designed. When you turn the input, the moon pointer waxes and wanes on schedule. Turn to the back again, where big cycles teach patience. Lay out the spiral of months, so a pointer walks one cell per synodic month. Mark eclipse notes into those cells, kind, direction, and hour offset. Add a small subsidiary dial to correct the running time when cycles drift. The metal remembers patterns, the pointer only reveals them. Line spacing must balance eye comfort against the limits of engraving. Any scratch becomes a datum, any burr becomes a future error. Back on the front, give the sun a clean pointer, and the zodiac clear markers. Shared factors reduce part count. Shared shafts keep alignment honest. But sharing means tolerant stacks. Keep your concentric tubes true. Better to remake a tube than to fight a wandering needle forever. That ring will drift against the stars. The owner can realign it season by season. A good instrument shows only what the moment demands. Clean the case. The machine must look humble and inevitable. Back to the workshop reality. How did they hold such thin wheels to cut? A bow drill opens pilot holes. A hand-turned mandrel trues small diameters. Toolmarks tell this story. Saw strokes at roots, file facets on flanks. Look closely and you'll see the metrology habits behind the craft. Scribes set the addendum circle, files, chase it carefully but not obsessively. Consistent contact keeps transmission smooth and arrow-bounded. Off-center arbor holes add periodic wobble. Compensate with larger clearances. Backlash lives in every mesh. Put correction mechanisms where slot matters least. Let the low-resolution cycles tolerate more looseness and still read cleanly. If you hear scrape, stop. One tooth is proud or one hub is drifting. The target is fluent motion, not brute torque. Build subassemblies on the bench, a shaft with 2 gears pinned and spaced. Only when 3 subassemblies spin freely do you stack them on their tubes. When everything turns, step back and do what makers always do. Roll the input a handful of months and see if phases agreed. Correct large ones by remaking the smallest offender, not the biggest. Materials rhyme, bronze on bronze, wood around metal, parchment to explain. Craft rhymes, same files, same drills, same muscle memory from wheel to wheel. And if a different master copies the plan, his errors will rhyme with yours. Modern imaging reads inside surviving fragments to recover those constraints. From numbers on scales and counts on wheels, the design grows back. One reconstruction favors shared gearing across several pointers to save space. Both are viable if the case can close and the dials still read clearly. So the best reconstructions start from the texts, not only from the dreams. And the making explains the limits. What can be filed is what will be built. What holds it together is discipline, not modern machinery. Pointers sweep, windows advance, the back spirals tick from cell to cell. The first astronomical calculator was not born in theory, it was negotiated in a shop. And that S the lesson, the genius ISNT. Only the equations, S, the engineering of the equations. Next episode we'll build a wheel from scratch and prove the slot tan pin anomaly on camera.